Hello, students. Welcome back to our dirty topic this week. We are going to be continuing with the topic of soil. Now, if you recall, yesterday we talked about the different parts of soil and we finished up with a discussion of soil texture. Remember, soil texture is essentially the proportion of different sized particles that make up soil. And on lab day, tomorrow, we're going to be exploring this with a hands on activity. So prepare to get your hands dirty tomorrow as we will explore a little bit more about soil porosity and soil texture. But today, we're going to take it a little step further here, and we're going to be discussing today what you see if you dig down into the soil, and we'll be exploring, some factors that can affect the development of what's called a soil horizon. So let's get to it now with our discussion of a soil horizon. A soil horizon can be described as the layers in a mature soil. Now, that doesn't mean that some soil is silly and some is mature. It's not that kind of mature. The word mature in this context means that it has been around for a while and it has been fully developed. Because just like many other things in nature, soil changes over time. You may recall earlier in the year, we learned about a climax community. And that is what you can expect to exist in an area after a long period of time. Well, likewise with a soil. A mature soil is one that has fully developed over a long period of time, and it's not going to change much anymore. It's mature. So this is an example, this picture here is an example of digging down beneath the O horizon where the organic matter is, into the A horizon where the topsoil is, down into the B and the C horizons. And you can see in this picture here, there are distinct layers, what we call in soil science horizons, because they typically are flat and horizontal, just like the horizon when you see the sunrise or the sunset. But these soil horizons are distinct and noticeable. By the way, for scale here, I have my compass. There's a compass, a hand compass, so you can see how deep this particular hole has been dug. Now, a soil profile is a cross section of a soil horizon. So if we dig down deep enough and we want to illustrate that or represent that in a picture, a diagram, an illustration, a drawing, we would call that a soil profile. So from that previous picture of an actual soil horizon, here's a cross section of that soil horizon with labels. And you can see the O horizon, the A horizon, the B and the C horizon. This is a pretty accurate soil profile or a cross section of the previous soil horizon. So let's examine each of these horizons, starting at the top and working our way down, beginning with the A horizon. The A horizon, which is typically right under the debris layer where all of the rotting leaves and vegetation and animals might be. The A horizon is also known as the topsoil, and it's the layer made mostly of humus. Remember, it's humus, not hummus. Humus is a lot of organic material. And as we discussed the other day, this A horizon typically is dark in color because of the organic material that is decomposing that makes it up. Topsoil is what you want if you want to grow a nice lawn. Topsoil is what you want if you want to grow a garden. Topsoil is good for growing plants. And as the name suggests, it's only the top layer of soil. As we go beneath the topsoil, and we'll get to that in a moment, but it's the topsoil that provides the minerals and the moisture for plants to grow on. Topsoil is a very important resource around the world. We saw that one video yesterday about the lake that dried up, and you can see the effects of desertification. In our own country in the 1930s, oh gosh, almost 100 years ago now, the whole Midwestern U.S. it was experiencing a drought, and we had terrible storms, windstorms called dust bowls. The Dust Bowl, a decade of dry weather, literally blew the topsoil off the land, and it exposed the soil underneath the B horizon. And the B horizon is not nearly as good for growing crops as the A horizon. So when you blow the topsoil off, or you wash the topsoil off with erosion from other factors, it exposes the B horizon, which is the layer below the topsoil, and it's the layer in which the minerals are leached from above, so it still has some capacity to provide minerals to plants, but not nearly as well as the topsoil. And during the 1930s, during the Dust Bowl, if you know about U.S. history, you know about the Great Depression and the Dust Bowl and how farmers were starving to death because they couldn't grow crops anymore because the topsoil was eroded away from the wind. And so topsoil is super important locally, regionally, and nationally from one time period to another. All right, let's dig a little deeper into this topic with the sea horizon. The sea horizon is otherwise known as weathered rock. It is the layer below the topsoil, and it extends down to the parent rock, also known as bedrock. The sea horizon is not really capable of growing any plants. There's no organic material in the sea horizon. The sea horizon is kind of what the planet Mars is like. We have a number of rovers exploring the surface of Mars right now. And much of what we've seen on Mars is just weathered rock. Yes, there are seasons on Mars. There's wind on Mars. There's evidence of past flowing water on Mars. And there's plenty of visible evidence that the rocks on Mars have been weathered away. But there's no evidence to suggest that there's any organic material on Mars. There's no evidence of past living things, and there certainly isn't. If you dig a hole, and we've dug holes with our rovers on Mars, there's no evidence of any A horizon or even B horizon in any. I won't even call it soil on Mars because it's really just dirt, Martian dirt. But let's explore this a little deeper. So again, a mature soil is a soil profile old enough for all three soil horizons to form. So in this picture, we've got the C horizon on the bottom. Above that, we've got the B horizon. Above that, we've got the A horizon. And here we've got the ground surface on the very top. I can't tell whether there's leaf litter there or not, but that would be the organic layer or the O horizon. When you've got the full development of at least the three horizons, A, B, and C, to form in an area, then you know that you are looking at a mature soil. That isn't always the case. Sometimes you don't see a mature soil horizon, especially if, let's say, you live in an area that's a development. And in order to build the home that you live in, maybe all of the topsoil, the A horizon and much of the B horizon was removed with big machinery. And your homes were built, and then only the A horizon was built back or brought back so that you could grow a lawn. If you dig a hole in your yard, you may see that you go immediately from an A horizon to a C horizon. Well, you can tell, a soil scientist can tell that that soil has not been around very long because it hasn't developed the various horizons. It takes more time for the minerals to leach out of the A horizon and form a distinctive B horizon. In fact, it may take 100 years in order for a mature soil to develop. That's a century. That's older than I am. So I am younger than a mature soil. That's an interesting thought. All right. Anyway, so you got the idea. It takes a long time for a mature soil to develop. Now, speaking of the development of soils, what are some of the factors that can affect the development of a soil? Let's go through a list right now, and we've just kind of mentioned the first one. The first factor affecting the development of a soil is time. A mature soil can't develop in just a couple of years. It takes a long time. And as I mentioned, on average, it takes about 100 years to develop a mature soil. So make sure in your notes you're writing down what is written in parentheses here, and pay attention to this symbol here, that little squiggly line that looks like a snake. That's a mathematical term that you'll see in science not unfrequently. That means about, not is or equal to, it's about. So the time, a long time is needed, about a century, about 100 years. If it takes another 10 years or a little less than 10 years from that, we're not talking exact measurements. Second factor should be familiar to you. We spent last week discussing this factor, and that is erosion. And you hopefully remember from last topic what some of the agents of erosion are. In fact, you might want to pause this video and list the agents of erosion. All right, the third factor affecting the development of a mature soil is climate. If you are in a warm and moist climate like a tropical rainforest, somewhere closer to the equator, it's going to develop a mature soil profile a lot faster than if you were in the tundra in a cold and dry climate. The development of a soil is going to be very, very slow. So when you talk about that, about 100 years to develop a soil, it probably changes by a factor of 10 when you're talking about the extreme changes in climate from the tropics to the poles. Big difference when you're talking about the climate of a particular area. And if you think about it, it makes sense because there's a very different type of biological activity and biodiversity in these different biomes in the world that are affected by climate. You got a lot more opportunity to grow multiple generations of plants or animals in the tropics because it's conducive to that year round. Whereas in the Arctic region, the development of dead organic material, it's going to take a long, long time, especially since those areas may be covered by ice and snow. We'll probably pick this up more later on as well. But there's some interesting developments in the soils of Arctic regions because the permafrost, which describes soil that is frozen year round, because of global warming, the permafrost is melting. And so the soils in tundra regions is beginning to change again markedly after being frozen for 10 to 20,000 years. So some interesting changes on the way regarding climate and soil. All right, that brings us to the fourth factor that affects the development of a soil horizon, and that is the type of rock. We watched a video on Monday, if you recall, about the different types of soil being formed by different types of things, including rock type. The harder the rock, made out of more quartz, you're going to have a different type of soil than the type of soil that forms with a shale rock, which is much softer. Generally speaking, sedimentary rocks, like the shale I mentioned, is going to develop a soil, mature soil, a lot faster than igneous or metamorphic rocks because of the crystalline structure. The crystalline structure of igneous and metamorphic rocks is so much more solid, and you can have larger or smaller crystal sizes, as we learned in geology in the first unit. But the development of a soil is going to be much slower, primarily because it's going to take a lot more time for those rocks to be weathered or eroded first, because you've got to have weathered rock before anything can even start to grow in those areas and develop a mineral layer in order for more plant growth to appear and develop over time a topsoil. So there we have our four factors affecting the development of a mature soil. All right, now for the remainder of our time today, I would like to introduce the activity that we're going to be doing tomorrow, at least one of the activities that we'll be doing tomorrow. You see, one of the things we'll be doing tomorrow is examining soil texture. And if you think back to yesterday, that triangular graph, you're going to have a lot of opportunity to explore that triangular graph in order to determine a soil type based on its different texture. Now, I'll review this again tomorrow, but I want to introduce it to you today, because what we're going to do tomorrow is we're going to have a sample of soil. And the soil we're going to be using is going to be a very dry soil. I have removed all of the moisture from the soil. And we're going to use a device called a soil sieve. And this soil sieve is going to be used in order to separate the different soil size types. So we're going to be removing the large gravel and the small gravel. And I'm not going to show it to you here because this is part of the cool thing with tomorrow's activity. You're going to be using this soil sieve to separate out the different components, including the large gravel and the small gravel. And we're not going to use those things to measure our soil texture, but rather we're going to be relying on the sand, the silt, and the clay. And we're going to be measuring the amount of large sand, medium sand, and fine sand, and we'll be combining those together into one category that we call sand. We're going to have a proportion, we're going to have numbers that we're going to collect to represent the proportion of sand, silt, and clay. I'll also show you different ways that we can go about measuring this with both dry soils as well as wet soils. So once we have the numbers of our sand, silt, and clay, we'll know that if you add those three together, that will equal the total, and the total is going to be 100%. So the total soil is going to be 100%, but we're going to break it down into the various percentages of the amount of sand, the amount of silt, and the amount of clay. And so when we calculate those numbers, which I'll show you tomorrow, we're going to get percentages. If you add three percentages together, it should equal 100%. So when we're doing our activity tomorrow, if you come up with, say, sand is 100%, silt is 120%, and clay is 150%, you know you did something wrong with the math because those three numbers don't add up to 100. They would add up to a lot more than 100. So watch your numbers tomorrow as we go through the activity. But once you have those three values, then we will be using this triangular graph, and we'll be plotting the numbers on our graph, the percent of clay, the percent of silt, the percent of sand, and where those lines intersect will give us a region on this texture triangle, and we'll be able to use this graph to identify exactly what type of soil that sample would be called. Would it be a silty clay, a clay loam, a sandy clay loam, a silt loam, or any of these other categories? So that's one of the things that we will be exploring tomorrow. Another thing that we're going to be exploring tomorrow is what we referred to the other day as soil porosity. And I'll be sharing with you tomorrow the details of how we will do this. But if you think of a container filled with soil and you have your magical magnification glasses on and you are able to see the various soil particles, whether they are large, medium, or small particles, you would be able to see the empty space between the particles. Those empty spaces between the particles is what we describe as the pore space or the soil porosity. And in order to determine soil porosity, we have to consider the total space of a container in which a soil sample is found. And the total space would be equal to the space that the particles take up plus the empty spaces. Think about it. The empty space plus the particles would equal the total space that this container encompasses. So if we have a container of a known volume, which is what we will have, and we know how many or what the volume of the particles is, we can do a simple subtraction and determine how much empty space is in there. And so we would be able to find the porosity of soil by taking the pore space, which would be the empty space, and dividing it by the total space. And by doing that math, we would come up with a percentage because we would multiply that number by 100. And so we would be able to calculate soil porosity, which is what we will be doing because we're going to have a volume of water, which will be representative of the empty space, and the volume of the sample, which will be the total space. And we'll multiply that by 100 after dividing. And so we're going to be able to calculate soil porosity. Now, if this discussion of soil texture and soil porosity made you feeling dirty, don't worry about it. I just wanted to introduce it to you today because we're going to work with it tomorrow, get our hands dirty, and hopefully by doing that and working through the calculations together as a class, it will make more sense. But what I want to emphasize to you right now in closing is this: soil texture and soil porosity are very, very important measurements of soil. If you are a farmer, if you're an excavator, if you're a builder, if you work with soil directly, or if you're just a homeowner and you want to build a house and you're building it in an area where you need a septic system, like in our township here, or something else, or you want to grow certain plants, if you're a farmer, you need to know something about soil texture and soil porosity. Even more than that, you would need to know a lot about the soil chemistry, which is a topic for another day. We're not going to get into that this week, but you need to know a lot about soil in order for you to be successful at your job and in order for you to be successful in what you want to accomplish with a piece of land. So, soil texture, soil porosity, we're going to explore it more tomorrow. Hopefully, you'll come to understand it a little bit better tomorrow as well. But for now, we're out of time, so we're going to call it quits. And so I'll say bye bye.